All right, guys, this is our third example. So as you can see, we have a lab splice connection in tension member, and we want to determine the maximum design force and star that can be transmitted. All bolts are M20 8.8/S. All welds are 8 millimeters, E48 SB felt welds, and the steel plates are grade 300. You have to recognize from here that we have a weld here, and we have the bolts in the other way, other direction. So another thing that you have three plates. The top one and the last one are identical. So when you make analysis, you have just to make analysis for one of them, and then also you have to make an analysis for the one in the middle. So you have gonna check the one at the top and the one in the middle, or the one is the top and the last one are identical, so the same. And also you're gonna almost separate them. So you're gonna work, for example, and the bolt side first, and then go and check the weld part. All right, so this is how we're gonna do it. So the first thing you can see here that we have the plates in tension. We have also the bolts are in shear because of the force, and we also have bearing and tearing. Also, we have our welding here applied to the end star, so we have to check the welding capacity, felt weld. So we're gonna start now by making analysis for our the blades in tension. All right. Okay. So the first thing that you have to recognize is the top plate and the middle plate are not the same in the size. So you have the top plate and the last plate. Actually, you have 35 plus 110 plus 35. So this is actually going to give you um, 180. So when taking a section, because when talking about place and tension, you have to take the section which is perpendicular to our direction of the force. And this is our force. You can see here, this is the direction of the force. So we're gonna take a section here, and the section gonna take it in to get the area cross and the area net. And the area net, when you're gonna take the area net, you're gonna subtract our area gross um, from the voids that because of our pulse here. And to do that, you're gonna have check that two plates, the top and the middle one. So to make a section, you're gonna have this, for example, for the top plate. Okay, this is 180 millimeters, and the thickness is going to be from here is 12 millimeters. You can see that they are identical. So 12 millimeters. All right. This is for top and last blade. For our second blade, is going to be like this. Let's see. All right. This is going to be, you have here, it's 200 millimeters, and the thickness is 20 millimeters here. So we're gonna have 200 millimeters here and 20 millimeters in that side. And when you're taking a section, you will have two bolts, and then you have this is for the area gross, you're gonna just multiply 180 by 12 millimeters and get the area gross for the section. And then when you're taking the area net, you're gonna take subtract this area by the area of the voids here. And this is actually depends about the DH, and DH depends about what type of bolts are having. So if M20, we're gonna say assume that we're using a standard pulse, and according to standards, M2 if the bolt's size is less than or equal to 24 millimeters, so you're gonna take the DH is equal to 20, which is the diameter plus 2. So we're going to have to have a void here for the bolts is 22 millimeters, and this is here and here. So you're gonna have, this is when you take it, so you're gonna have one here and one here, and also the same thing here. All right, and this actually is going to be, as I said, you will have to calculate according to standards, and we're using M20 standard, so it's gonna be the void is gonna be 22 millimeters. So that's it. So we're gonna go to our axle and just apply what we have here to calculate and check the tension place. So we go here. All right. So I'm gonna clear everything and write it again. All right. So the top plate, our first, for example, we have the number of plates. We have one at the top and one at the last. So when the number of plates we're having as a splice plates is going to be two. So two splice plates we're having and one main plate. All right. So the thickness we're having in the question, we have one is 12 millimeters and the main is 20 millimeters. All right, for this one it was 180 millimeters and this one's 200 millimeters. The edge distance, okay, we didn't get the edge distance. We'll go back. Let's go. The edge distance is actually 35 millimeters, so we're gonna have to add this one here. So 35 millimeters. All right, and the overlap distance is actually the distance between the first and the last bolt. So you go to our example. This is I'm extracting all the information for all the analysis, not just for tension place and tension. For tension place, you just need the blast thickness and the section, and that's it. And you have to get the KT, as you can see here. It's almost symmetric, our steel connection, so the KT is going to be equal to 1, and we're gonna check that later, but this is obviously going to be 1. We have already discussed that. However, I'm gonna check it also. All right, so we're talking about the overlap. So the overlap distance is between the distance between the first and the last bolt. So as you can see here, it's 70 millimeters. I'm gonna make it like that. This is okay. So go back. All right. All right. We have an overlap distance is 70 millimeters. The bolt type that we're using is M20, and we're using S. I think S, and yeah, we're using S and 8.8. So we're gonna use S 8.8. So that's what we're using. Number of bolts we're having is 4, and number of bolts in the section is going to be 2. The steel blade grade is actually 300 given the question. All right, so when we go to the place and tension, that's it. So the first law we're having, this is from the standard for your reference. Okay, this is IS 4100 from the reference, so you can go and check that from a certain standard. Okay, so you just apply the N star. It must be less than 0.9 NT. The NT is the lesser from the area gross multiplied by F yield, which is the 300 given, or you go and calculate also the 0.85 KT. As I said, KT you get it from a table. AN is the area gross minus the area voice, what we're having for the for our bolts, and FU is the F ultimate for the 300 megapascal. You have F ultimate is 440. So to get the KT, I said is symmetric. So however, this is actually from the standard and this is from another reference. So we have a symmetric shape. So when you have a symmetric shape, is always 1. All right, symmetric shape is always 1. However, when you have a leg, we don't have a leg in our case, but if you have a leg, so it depends. If the leg is symmetric, so you have 0.85. If the leg is not asymmetric, so you're gonna have 0.75. All right. this is actually, you can see which type of connection you're using, and you can get how much KT. So this is also another reference to give you some clarification about that. So you have here one called symmetric one. This is when you have some kind of shape like that, and this is when you have identical leg, so 0.85, and when you have difference leg, you get a 0.75. So in our example, we're gonna say okay, we have to calculate AG Fy for the section capacity, and we have to calculate the under equation. So the plates, the supply plate is going to be this one. So the area gross is 2000, 2160, and this is, we got it from multiplying our 180 multiplied by 12. All right. If yield is 300 megapascal given the question, and this is now the AG multiplied by Fy. This is for our first formula. To get that is 648 kilonewton. And now, as I said, that the KT is actually having a symmetric shape, so the KT is 1, and the area net is going to be A gross minus the number of poles in a section. We have 2 multiplied by DH multiplied by the thickness of the blade. The thickness of the blade we're having here, we're talking about the top and the last blade is going to have 12 millimeters. And the DH, it depends about the pole type. We're having M20. So you go here to the standard and say, okay, I'm using a hole type standard. The DH is actually depends about whether our pole size diameter is greater or less than 24 millimeters. So we have M20 means 20 millimeters. You go here and say, okay, this is our DH. DH is going to be DF. DF, the diameter is 20 plus 2. So that's what we're going to be using. You're going to say, all right, we have DF plus 2 from the standard type, and DH is going to be equal to 22 millimeters. So now the AN, after you just applying this formula, AG, what we got above the 2160 minus 2 multiplied by DH, which is 22 multiplied by the TB, thickness of the plate is 12, you're gonna get AN is equal to 1632 millimeters square. All right. So if ultimate actually depends on the table, you can go there as already shown in previous example, but I can go here and see. So 300 is going to be 440. All right. So let's go back. So according to table, you're gonna say F ultimate is equal to 440 megapascal. All right. So you just calculate just normal multiplication for all the above, and you got 610. So now the NT must be the lesser of our previous formula and the other formula. And you got here that we got from the first formula is 648, and from another formula is 610. So we're going to take NT is equal to 610. We're going to apply our factor 0.9, and we get that the N maximum in the plate on the top is actually equal to 549. All right, 0.83. This is the top of the splice plate, how much force can transfer it to this plate. All right, and as we have 2 plates, so you're gonna apply for the both of them. I'm gonna say, okay, this actually going to be transferred into 2. So apply, multiply this. This is for 1 plate, multiply by 2, so you got 1098. Obviously, the next plate, the main plate, it seems gonna be smaller because this is a very huge force be transferred in our plates. And let's go to our next one. So you can see here that we're gonna go to the next step with the same procedures. So you're having here 20 multiplied by 200 to get the A cross. All right, 20 multiplied by 200 to get the A gross, and then the Fy is 300 AG multiplied by Fy, you get it 1200 kilonewton. So the KT is the same from the table is 1, and then we got the AN, the same thing we're having. So you got the DF from the standard, the same, because we're having the same thing for everything. This is the same. So you get AN is actually going to be 3,120 millimeters square. And if U is going to be 440 megapascal, and this is when we apply the under formula, we get 1,166.8. All right. So now we have to take the NT is the lesser of the 1,200 we got from our previous, or the splice plates, we got it from here. No, this is okay. This is actually for we'll still in this process, so we get it. And NT is the lesser of 1,200 is from here, from the area gross multiplied by Fy, or 1,166.9 we get it from the other formula. And we're going to use our let's say the NT is 1,166.8. So we apply our factor 0.9 to this port, and we get 1,050. So it's the same procedure. So we just very simple. And now we take what is the maximum tension can be transmitted, the maximum force can be transmitted in our plates is actually the lesser from both. So you can see here that the main plate is capable to carry 1,050. However, our two splice plates can carry 1,098. So we're gonna see that the maximum force can be transported in tension is going to be 1,050, which is for the main blade. This means the main blade going to be fail before our splice plates. Okay, that's it for our tension. It's very simple. As I said, it's just you apply this formula, and then you get the AG Fy, apply this one, and then area gross by F yield, and you apply also the under formula, the area net, and you got which one is lesser. The one is lesser is actually going to be your N net. You apply 0.9 to your N net to get how much force going to transfer it. But don't forget that when you have two plates, that means your force is going to be multiplied by 2. If you have 3 plates, for example, in one direction, so it's going to be multiplied by 3. So the number of plates you're having in carrying the load, you have to multiply it after that one. So that's one thing you have to carry. That's it. The KT, as I said, you can get it from there, and just apply the same formula. All right, so this is actually we have now checked the tension in plates for both of them. All right, so we'll go now to the shear impulse.